In my previous videos, I have criticized Darwin and his ideas on evolution. I'm not the only one who has done that. There have been many before me that have disagreed with Darwin's ideas on evolution. But no one has ever produced a new model evolution to say, okay, if Darwin's ideas were wrong, then how did evolution work? How did life forms change over time? The difference is that on this occasion I have. And I have done that in my book, Human Ascent. And this is, of course, the front cover of my book. And it is not just a pretty picture. The girl and the boy standing on top of the primates, because we evolved from the primates or from the natural world, see an entirely different world, an entirely different reality. And this is the holy grail of evolution, to explain how it is that we evolved from the natural world and yet our reality is completely different. In this video, I want to start at the beginning of evolution and explain my model of evolution and this process up to the arrival of humans. So I think there's no debate about that life started or commenced about 3.5 billion years ago in the form of a single-celled organism. And single-celled organisms were the first arrival of life on Earth. Just to talk about single-celled organisms has no meaning. We need to give them qualities. We need to understand the single-celled organism. And we can safely say that single-celled organisms have an extremely high level of instinct, or innate or inborn survival knowledge. They just know how to do things. And it is this instinct or inborn or innate survival knowledge that allows them to adjust rapidly to any environment, whether friendly or hostile. They just know how to survive. Another characteristic of single-celled organisms is that they reproduce by cell division, cloning, or replicating themselves. And this is an extremely effective way of reproduction. Imagine that there was one person in the world and that this one person would use replication or cloning to reproduce. In less than 24 hours, this one person would have populated the entire world. With that example in mind, just imagine how many single-celled organisms there are in the world today. Because that process of cell division or replication is still continuing today. Because single-celled organisms use replication or division to reproduce, they're completely autonomous. And because of this, you could say that they have no attachment to any other organisms. They don't need anyone to survive. And because they're so autonomous, you could say that single-celled organisms have the lowest level of emotions or attachment. They're only interested in themselves. They have no connection with other organisms. And because of that, you could also say that single-celled organisms have the highest level of egocentricity, self-centeredness. And because of that, there is no change in life forms over the first 3.5 billion years of life on Earth. They reproduce by cell division, which are identical cells of the parental cells, and because of that there is no change in life forms over time. But then something remarkable happened. About 450 million years ago, the characteristics of male and female were separated, each in their own cell structure. And this heralds the commencement of evolution, or the change of life forms over time. And we could say that the female is identified by 2 X chromosomes, and the male is identified by an X and a Y chromosome. And it is the change in these chromosomes that produces the change of life forms over time. It is not because there was a meteor strike, it's not because there was a great flood or an earthquake. It's because these chromosomes changed that life forms changed. But when we discuss chromosomes, it makes no sense. We need to understand them, we need to ascribe qualities to them. And this is really not complicated. And the reason for that is that the female carries 2 X chromosomes. So it's safe for us to ascribe qualities to the X chromosome by identifying the qualities that we attribute to the female. We can actually safely say that those qualities are the qualities of the X chromosome. So what I'm saying is that the female behaves in a certain manner because she expresses the 2 X chromosomes that she carries. So when we identify the qualities of the X chromosome, we can safely say that they have qualities of nurturing, that they have qualities of caring, that we align with the female, comforting. And this is usually in relation to the care of her offspring, protecting or shielding, being tender, being kind, sensitivity, compassion, empathy. So if we bundle these qualities of the female characteristics together, we could safely say that the X chromosome represents emotional attachment or affection. And the male carries an X and a Y chromosome. And because the characteristics of male and female were separated shortly after the single-celled organisms, or they evolved from the single-celled organisms, we can safely say that the Y chromosome represents instinct, or inborn or innate survival knowledge. And it is a change in these chromosomes by interacting with each other that determines the change in life forms over time. So, in the beginning, there was a single-celled organism. That's how life commenced on Earth. And I don't think that there is a dispute about that. Now imagine that all these chromosomes were in one single-celled organism. The behavior of that single-celled organism could not affect an individual chromosome. And the reason is because they're not isolated, they're all bundled together. So for the first 3.5 billion years on Earth, there is no change in living life forms. Reproduction or is by replication or cell division, and the divided off cells are identical copies of the parental cell. And then we got the separation of the cell structures of male and female, the characteristics of male and female, each in their own cell structure. Now suppose that the female could affect the expression of the X chromosomes that she carries. And if we understand that the X chromosome represents emotional attachment or affection, she could perhaps do that by rejecting or not caring, and thereby diminish the expression of the X chromosome. She could not possibly increase those qualities, because to do that, the female would require another X chromosome. But suppose he was successful in lessening the expression of the X chromosomes that she carries. As soon as she mates with the male, who also carries an X chromosome, those qualities would probably be replenished. So her endeavor to reduce the qualities or the expression of emotional attachment or affection would be futile. Now if we go to the male, suppose the male would be able, through his behavior, reduce the effects or the expression of the X chromosome that he carries. As soon as he mates with the female, that would also be replenished. So in relation to emotional attachment or affection, the male and the female really cannot influence much the expression or vary the expression of emotional attachment or affection. But what the male could do, the male could actually affect the expression of the Y chromosome. And if he does, that could not be replenished or restored when he mates with the female, because the female does not carry a Y chromosome. So if you understand that the Y chromosome represents instinct or innate or inborn survival knowledge, then the male must show a blatant disregard for his own well-being. He must self-sacrifice, put his life at risk to reduce the expression of the Y chromosome or of innate or inborn survival knowledge. And this is exactly what we see over the entire course of evolution. What we see, a continuous reduction on the genes of the Y chromosome throughout the entire course of evolution. The Y chromosome has continuously shed its genes until the arrival of humans. Once humans arrived, the Y chromosome has not shed a single gene. So you could say that when we arrived, instinct or innate or inborn survival knowledge was at its lowest level. And we can perhaps best illustrate it like that. A very tiny Y chromosome. There has been numerous journal articles written on this fact, actually arguing that the Y chromosome would go extinct. But of course, when we arrived, when humans arrived, it has not shed a single gene. But I can perhaps better put it in a graph form, like this. And the bottom part of the graph represents instinct. And the top part of the graph represents emotional attachment or affection. And as you can see, evolution starts on the left and instinct is really high. But then over time, it continuously reduces. And as you can see, emotional attachment starts at a very low level, but over time, it continuously increases. So that is the direction of evolution. Evolution is only one way. It never goes back. And the bottom part is instinct or innate or inborn survival knowledge. And it continuously decreases until the arrival of humans. And the top part represents emotional attachment or affection, and this continuously increases, and it's still increasing today. And this is the range of evolution. From the beginning to the end, it would cover a time of 450 million years. And these are the levels of evolution. And the levels of evolution are the levels of instinct and emotional attachment. And this graph represents evolution, and it is a fundamental law of evolution. That means without this process of reducing instinct or increasing emotional attachment, there is no evolution. There is no change of life forms over time. This graph explains every facet of every animal and also our behavior over the entire course of evolution. So the first animals after the single-celled organisms were the insects. And as you can see, insects have a really high level of instinct and a very small level of emotional attachment. Following the insects are the reptiles. And the reptiles, as the graph shows, have a lesser level of instinct and a greater level of emotional attachment. The reptiles emerged only because instinct had reduced in animals to such level that it can no longer be expressed by the insect bodies. And that is why a new life form emerges. Following the reptiles are the birds. And again, the birds emerged not because they are better at surviving or because there was a meteor strike. It is because in them, instinct had reduced further and emotional attachment increased to the point that the bodies of the reptiles can no longer express the new levels of instinct and emotional attachment. And after the birds, we have the monotremes, and after the monotremes, we have the marsupials, and of course from the marsupials, we have the mammals. And I will explain these changes in animals according to this graph in my following videos. And of course, finally, we have humans. And as you can see, with the arrival of humans, instinct has leveled. It's no longer reducing. I have actually separated 3 levels of intelligence in animals and in humans. And I have called the first level of intelligence instinctual intelligence. And that is really confined to the insects. Okay, the reptiles, the birds, the monotremes, and the marsupials, I have colored orange because this is really a transition stage from the insects to the mammals. And you could call it the intermediate phase. And with the mammals, I've called their intelligence biological intelligence. And I will explain these differences and why I have lumbered the reptiles to the marsupials together. And once you see their behavior and the way they reproduce, it makes very good sense. And then finally, we humans arrived. And our intelligence is psychological intelligence. And I will explain that. And I have explained that in my book. But for now, I just want to return to the insects and discuss them a little bit. So as you can see, over that range that the insects emerge, there is already a slight drop in instinct and an increase in emotional attachment. And we can see that in the insect behavior. So for instance, there are spiders that lay their eggs and abandon them, that have absolutely no care to their offspring. And there are spiders that actually lay their eggs and protect them for a little while. Emotional attachment is increased in this spider species. And then there are spiders that lay their eggs and protect them, and when the youngsters emerge, they jump on mom and she carries them around for a while. So there's different levels of caring even within the insect phase, and that is what this graph shows. But as you can also see, there's an extremely high level of instinct or innate or inborn survival knowledge. And that's obvious. Because the little spider is born and he goes his own way and he can weave a web despite the fact that he's never seen one before. This is innate or inborn survival knowledge. But what we will also see, because instinct is reducing, that the male spider or the male insect must always put his life at risk. He does something that could bring detriment to him. And what I will do, I will go into nature, and I'm in Cairns, Queensland, Australia, and I will film insects for you. And I will show you that the insects behave in a certain way and are actually they're physically expressed in a certain way that will bring risk to the male. And after I filmed the insects, I will film the reptiles, and I will film the birds, and I will film the monotremes, and I will film the marsupials and the mammals, and I will show that the trajectory is always the same. It will never deviate. And you know, life cannot be any different. It's a continuous process. But enough now, I will go into nature, and the insects that I'm thinking of are, for instance, the golden orb spider, the bird-winged butterfly, and perhaps if I'm good enough to film them, the Ulysses butterfly. And I will present that in my next video, and I will discuss their behavior, and from then I will go to the reptiles. Before you go, if you would like, go to the link below and you can order a copy of my book, and you can read for yourself how evolution progressed and how we emerged from the natural world or evolved from the natural world. And please don't forget to like us, and please subscribe to my channel, and if you enjoyed the video, please share it with your friends.